Having looked at the working example of an expert system, we move forward into what we call as inference mechanism and something called conflict resolution in the human mind. In the example that we looked at, and typically when you are looking at certain facts and rules, they add new information based on certain existing facts, which are case facts in the working memory, and then matching with the knowledge base, inserting new facts. So one fact lead to another fact, and that fact leads to another rule execution. And this in this way you started, if you remember, you started with a limited number, let's say two facts to begin with, then rule execution and adding new facts, another rule execution, and you get, you're adding more facts. So what you're doing is, what a human is doing and what the expert system is doing is actually inferring. Inferring means deducting, getting new information from a set of facts. So one fact leading to the other, and so forth. So in a way, you are moving forwards with your search strategy as well as reasoning mechanism. So certain examples, certain application areas are quite used to this kind of thing, where you're trying to discover new information. You're trying to discover what this means, okay? And in theorem proving, in analysis, given certain facts, what conclusions can we draw? And those conclusions, depending upon the application area, can mean many things, okay? So you start with a certain limited number of information or facts, and then after the knowledge base works and the rules execute, you add new information or knowledge to your system. That is forward chaining. As opposed to this, when you're trying to prove something or find out why this happened, what was the reason a particular decision was taken, or why a particular fact happened, you try to reason backwards towards those facts or those effects which caused that thing to happen. For instance, why did a particular software fail? Why was there an explosion somewhere in a factory? Okay, so there you're not trying to find new info, you're trying to find what caused, let's say, a fact to be asserted, fire in the factory. So there, in these situations, human beings and likewise expert systems, they try to move backwards and they try to find rules or facts that have caused this thing to happen. That is known as backward chaining, trying to prove something, as opposed to trying to find new information. So each of these mechanisms are routinely used by human beings in trying to find new or trying to justify a few things. Typical example of doctors. So you say, why did you arrive at that figure? And it tells you, moving backwards, these are the facts based on which I have come to this conclusion. Here I want to talk about something called conflict resolution. What exactly is it? Conflict resolution really means that if you look at the inference engine, and we've seen that example, the family example, there were a couple of facts and rules that could be executed at the same time. Now that really means that the doctor or the analyst was trying to know, he is unsure of what rule to apply when, okay? Because you can't apply more than one rule at a time, because you have to do certain bit of reasoning, okay? So that is what is known as conflict resolution. So typically what they do is strategy is fire the rule, first in the sequence. You look up all the rules that are being, are ready to be fired, pick up the first one. Or you could say more specific rules. A rule that has got more if conditions on its left-hand side. Let's say a rule has 6 conditions on its left-hand side. This is also ready to be executed. And there's another rule which only got 2, let's say, conditions. And that too is also ready to be executed. The inference engine, using this strategy can say, all right, I will always fire the rule that has got more specific information, which means more conditions on the left-hand side. That's one of the resolution strategies. Another way is said is another strategy is that execute that rule timestamped based on the fact last asserted. So based on the latest information provided to you, and based on that, whichever rule becomes executed, ready to be fired, execute that. And then, of course, there are two other things which are very important. One is to actually assign priorities to rules. There's one rule by default in human beings, which is already there, which is the emergency rule. And by emergency means you're driving a car, and you know certain rules that when there's red light, stop, and when there's green light, move on, and so forth, change gears, put on the brakes as required. But in an emergency situation, somebody steps in front of the car suddenly. Now, in that situation, none of the normal rules will be executed. There will be kind of an emergency rule which happens in your mind, says, forget about everything, put on the brakes. So that rule, in terms of priority, has got more weight as compared to others. And then there's a parallel strategy as well. You want to reason on a number of parallel decisions and then decide. Some domain areas like cameras, they've been using fuzzy logic for focusing. Very interesting. Medical diagnosis, mycene is a very good example. Recently, there have been others, whereby the results of expert systems analysis of actual data on X-rays obtained of human beings has performed 100% correct diagnosis, as opposed to experts who only could do 98% correct analysis. So the question is, should you consult the experts or should you consult the expert system? Process control systems, knowledge domain areas, faults in vehicles, engineering, and so forth. Finance and commerce, very interesting. Predicting what's going to happen, the effect of certain decisions, financial decisions, how they're going to behave and not. So those are the application areas, actual ones who are using these. And lastly, some expert systems tools. One of them is Jess, called Jess. The other is Clips. There used to be Prolog as well, programming in logic. Jess is an expert system shell for Java platform. Clips is an open source tool for building expert systems. The AMZ Prolog, embedded Prolog, own decision making, eXpert, programming in logic, syscorbid, and so forth. So these are some of those expert system tools that are being used to build expert systems. I hope this was interesting and you learned something. Thank you very much.